In this video, we are going to go over a substitution method application that I don't always necessarily use, but wanted to show you that you could use to solve a system of linear equations. So in this case, we don't have either equation set up so that we have a variable already on its own. However, in this first equation, if we were to add 3x to both sides, we would get y alone, which would lend itself well to doing substitution. I must give you this warning though, that generally speaking, I don't use this method of solving for a variable first and then using substitution unless no fractions are introduced into the problem by doing so. So for instance, if we were to solve for x here, eventually you'd have to divide by a 5 to get x alone, and that introduces fractions. If we were to solve for y here, we'd eventually have to divide by 3 to get y alone, which again would introduce fractions. Here, y will be on its own by just adding 3x, no fractions. So I take this guy off to the side here, and I have negative 3x plus y is equal to 5. I'm going to add 3x to both sides with the goal again of getting y alone. So I get 5 plus 3x is equal to y. And I'm more comfortable writing it as 3x plus 5, which is the same expression here. Now, what's the point of that? Well, that is this, and now that I have y is equal to 3x plus 5, I can replace this y value with that expression because y is 3x plus 5. So I have 5x plus 3 times y. And again, y is 3x plus 5. At this point, this becomes the same kind of substitution problem that you've seen in earlier videos. So I'm going to solve this equation like normal. I will multiply 3 to everything there. You'll get 5x plus, and then 3 times 3 is 9x. And then 3 times 5 is 15 is equal to 1. And now we keep solving by combining like terms. 5x and 9x is 14x. Plus 15 is equal to 1. And then subtract 15 from both sides because we're on our way to isolating x. It's a beautiful thing. 14x is equal to negative 14. Oh yeah. Divide both sides by 14. And we're left with x is equal to negative 1. Another reminder, x equals negative 1 is part of the solution. We're figuring out where this line and that line intersect, which will happen at a point, x comma y. So I have my x value. I'm going to plug x into this equation here to solve for y. So y is equal to 3 times x, just doing what this tells us to, and we're going to add 5 to that. So y is therefore equal to negative 3 plus 5, which is positive 2. So there's our solution in point form. That would be the point negative 1 comma 2. And as always, I'm going to check this answer by plugging in the x and y values into their corresponding variables in the other equation that we've not used to solve for y. So that would be 5x plus 3y equals 1. So we'll do our check. So I'll do that like right here, I guess. So that would be 5 times x, which is negative 1, plus 3 times y, which is 2. And the question is that equal to 1? And the answer is yeah. 5 times negative 1 is negative 5, plus 3 times 2 is 6, and negative 5 plus 6 is indeed 1. So we're right. Sweet.